Hey guys, this is Mike.
And I'm Joe.
We're from Systematic Automation, and today we're going to talk about cup printing, more specifically disposable cup printing.
So our first video, we want to talk about disposable cups, like you see here. Paper, plastic, and foam cups. We build a lot of machines, a lot of screen printers for these types of drinkware. This is a pretty easy application. This is pretty simple. So somebody who's printing t-shirts that might be getting inquiries to decorate cups, chances are they're gonna probably start with something like this, disposable cups.
Right.
The biggest reason is because, well, for one, the turnover, it's a consumable, so there's a lot of business coming in, continual business. And the adhesion here, for somebody who's just starting to print on cups, the adhesion isn't really a factor here. It's not something that you need to worry about because you're throwing them away. So other items like glass or pint glasses or tumblers, things where you need the logo to stick on there really well, adhere really well, your image, and be good for dishwasher safe applications. We're gonna have other videos that get into that, but right now we kind of just want to make it easy, talk about disposable cups. So you want to print on a paper cup. We call this a soft wall cup. The soft wall because we can squeeze these cups. They're soft wall.
Yes, so you're gonna have your mandrels. Mandrels are what support the inside of the cup so that you have a nice strong printing surface to print on. Without that, you've got a lot of play here. It's soft walled. You need to make it rigid. You stick a mandrel inside, now it becomes rigid, so now when you rotate the part, it's supported all the way around. So a lot of these, it's pretty much the exact inside dimension of what your cup is, fits nice and snug inside, and that's what's supporting your cup while you're printing. So this will be good for, any machine that you purchase from us. You're gonna have a mandrel, and we're gonna, ask you, what size cups do you want to print? Usually the standard, sizes, whether it's 12, 16, 24, you'll get a mandrel for each cup size that you want to print on. So that is the most important thing when you're printing cups, is you need a mandrel to support your cup. And then, from there, there's different tooling types.
Yeah.
Which you can get into a little bit.
Mandrel, like everything Mike just explained, and we'll make these mandrels out of different materials depending on the application, right? So what we're holding here and playing around with is a 3D printed mandrel. If you're using a machine like our semi-automatic model F1, a 3D printed mandrel is
more than enough.
Fine. We'll make mandrels, we'll turn them on a lathe out of solid chunks of aluminum, and in those applications it's because we're doing a curing process of the cup on the mandrel, and a 3D printed mandrel doesn't really like high levels of heat, getting hit by heat. A UV lamp on and on and on, constant 8 hours a day, it might start to warp the a 3D printed mandrel. But something like an solid chunk of aluminum mandrel, it's gonna take the heat just fine. So depending on the machine will depend on the type of mandrel that we're gonna machine for you and provide with the machine. You see us looking at our phones, we're just looking at the notes that we took. This is our first video, so.
A lot to remember.
There's a lot of stuff to talk about, and this is our first video of
just in general. There's going to be a ton, but this is the first, so we'll keep it to cup printing for this one. Another thing is, every time you add to your line of cups, all you got to do is send us a sleeve of your cups. We're going to take dimensions, and we're going to come up with this design. Our CAD guy is going to come up with this design, 3D print it or turn it on a lathe based on the drawing, and that's all you need every time you get into something new.
Yep. So let's say today you buy a machine like say a semi-automatic model F1 DC, that's a one-up machine. So you're gonna put one cup on the machine, hit the button, it's gonna print, you're gonna take it off, put another one on, hit the button, and just repeat that. And we'll get into the machines and stuff in another video, but just as a quick example. So like Mike was saying, you buy a machine today to print this cup, you get this mandrel, and now next month you want to print this cup. It's a paper cup. This is a foam cup, it's a paper cup. Different size, different diameter. Like you said, just send us a sleeve of those and we'll make a new mandrel. And this mandrel, you take it off of the tooling fixture on that machine, and then you can just slide the new one on and make an adjustment to the tilt and everything like that that accommodates the taper. And now you're printing that cup on the same machine for the cost of a mandrel. Super cheap, really easy, really versatile.
Yeah, and one thing just to add to that, you'll see on paper cups you got a seam. You don't want to print over the seam, so when you're loading, just remember you got to orient the cup every time you load it based on the seam in a particular spot on that mandrel every time you load it, so that when it prints and rotates, you're avoiding printing on that seam. If you do something like the T8SS and you want to load those by hand and have it automatically pre-register that, we have optical registration that will actually look for this so that your operator doesn't have to take the time and by eye load it like that. So there's different things we can do with seams. You guys as the operator can also take care of loading that just that way and eliminate any issue of printing on the seam. So
now the tooling types, let's talk about we have the 3 different tooling types here. So first one would be the easiest type of tooling, back to an F1 DC, and we even do it on the T8SS, is a friction drive tooling, right? So this is where we get into a little bit more details about the different types of drive methods of the cup. First one we're going to talk about is the friction drive. So this is sitting on a fixture, right? And there's a shaft here on the end. This slides onto the shaft. And your screen is above the cup here. And your squeegee is top dead center over the cup. And when the squeegee pushes the screen down and this screen moves, the squeegee pushing the screen down into the cup and then the screen moving, it's friction driving the rotation of the cup, right? Now, if you're printing a single color image, then friction drive is okay. Then we have other types of tooling, like a gear drive tooling. Now that gear drive tooling is we're controlling the rotational speed of the cup with a gear, and that gear we connect to the screen's movement. So as the screen moves, it drives a gear and it forces this speed to maintain at one speed. And that's when you're going to get into like multicolor.
Right.
The reason for that is with friction drive, you have 2 different types of, this is where like it gets into more detail, like I was saying.
Oh yeah, there will be a separate video for more in-depth explanations of that.
But yeah, we have friction drive tooling that's going to use the screen to spin, to rotate the cup as it prints. We have gear drive tooling that connects to the screen and forces the spin speed of the cup. And then we have other things like servo drive tooling, where we're actually servo spinning this at a certain rate in relation to the screen's movement, which would also be servo drive.
Yep.
Why don't you just touch base with them real quick and tell them the difference, the diameter difference, and why that wouldn't work friction driving multicolor on a tapered product?
Yep. So every time you do a friction drive print, you're never gonna print at the exact same speed. It'll be very close, but it'll never be exact. So you might, one cup will print and it'll drive at the speed that's, closer to the top, which is, slower than what will be down here. When it's smaller, it's gonna rotate faster. So if you look even on like McDonald's and Starbucks cups, all kinds of different cups, even in other types of printing, you'll see like a little ghosting on the bottom of the print or a little smudging. and the top, it'll be clear in the middle. Maybe the top, you might see a little something funky too. That is just the nature of printing, the nature of screen printing especially. So that friction, it's just picking anywhere on the cup that it wants.
It's guessing from cup to cup.
Yeah.
Yeah, one cup might print at the small diameter speed, and then the next cup, for any reason, the squeegee pressure, it might choose the large diameter and print at that speed. So that cup's going to rotate at that speed. Now, if you try to print multicolor, you don't have that one set speed. So now you have an image that's stretched on one cup, and then it's squeezed together on the next cup, and then it changes from cup to cup. So now you're throwing a second color down. You're never going to line it up with a friction drive system.
Precisely.
That's why we have the gear drive.
Now, when you do the gear, you're going to tell us, okay, we want, for the most part, they're always the same. We size it to the medium diameter of where your print area is going to be smack dab in the middle, but sometimes maybe you're printing closer to the top. So you'll tell us, I'm going to print, I don't know, a ½ inch from the top or 1 inch from the top. And we're going to size the gear to this exact location on the mandrel. So you're going to have your gear back here, and it's going to drive at that same rotational speed every single time. So now when you're talking about registering a second color, it's going to repeat the same speed for your second color that it did for the first color. And you can line those images up, within a few thousandths of an inch, even by eye.
Oh, yeah.
So
now, multicolor options. So if you said, well, Joe or Mike, we want to print multicolor on these disposable cups. We know they're just throwaway, but our customers, they want the multicolor. How do we do that? Well, you have basically two options. Option one, least expensive option, is going to be a gear drive piece of tooling, like Mike just explained, where that pitch diameter of that gear is sized to that medium area of your image area of the cup, right? So you have that piece of tooling. Now, when you go to put your cup on there, like Mike mentioned earlier, you're going to rotate the cup, and you're going to position the rotation of that cup when you're doing the second color, and you're going to stick it on. Now, how do you know just by looking at it to get the rotational registration just right? We make something called a mechanical pointer. It's a few $100. It's basically a little pointer that sticks on the tooling, and it points to a reference point on the cup, a reference point on the first image that was printed. Now, when you go to put the cup onto the mandrel, you have the pointer here, and you're going to rotate the cup, and okay, I want to point at that spot on the prior image every single time, and you stick it on. Now you have your screen adjusted to where when this thing comes down and performs a print, the second color image is going to rotate, the screen's going to rotate the cup, and the second color image is going to lay right in the same exact spot that you want it every time. And it's going to happen every time because you're using that mechanical pointer as a reference point to point to a reference point on the prior image. That's your least expensive way. So that's a few $100 option we can add to any type of gear drive tooling, or even friction drive if you're printing something non-tapered. So just to touch on that, the reason why we would gear drive something like a cup is because they're tapered, right? They're small here at the bottom, they're big at the top. The reason why friction driving a tapered cup for multicolor doesn't work is because the different diameter differences on a tapered product. Mike and I, we just talked about that, and different speeds at different times from cup to cup. Why don't you take them down the optical, start out and bring them down the optical.
So, yeah.
It's a little bit more expensive.
A little bit, to say the least. It's a good amount more, but basically what optical registration is it's replacing the operator having to find the leading edge of a previously printed image, or like the seam on a paper cup. So the operator is going to load, whether it's on the F1 DC or a T8SS, going to load. Maybe you got automatic loading for a T8SS, but neither here nor there. The optical registration is going to actually rotate the part, spin the part, this system that we sell, look for the leading or ending edge of a particular color. So your operator has to train the optical registration sensor from Keyence, correct? We use Keyence for
Typically,
those.
we use Keyence for our sensors and stuff, yeah.
They're going to train every new job for a particular color, so that it's going to spin at a very high rate, and just look for that color, the leading edge of whatever color you're picking to register off of. And then it gets to the print station, and it's going to, servo drive both the rotation of the cup as well as the screen. You're going to, input on the touch screen a particular diameter so that the system knows exactly what speed to drive both the cup and the screen, so that you have a perfect alignment of your second, third, fourth color, however many you're going to print, in relation to that first color. So optical registration takes human error out, even though, using a mechanical pointer, what Joe just explained, it can be pretty precise. You can get pretty close to what an optical registration can do. You're not going to notice, a huge difference at all by any means.
A mechanical pointer is going to do really well for you. Typically, you'd put a mechanical pointer on like the F1. If you're going optical registration, like a machine that we're building for a customer right now, that's on a T8SS. That's
it's higher production machine.
That's a high production. So let's talk about some machines. So typical machines that we sell for these disposable cups. Less expensive would be our model F1 DC. And then when you get in your throughput on that machine, your throughput on that is going to be about 600 to 800 cups per hour. That's realistic. That's an operator sitting there with a table next to them, somebody keeping that table loaded up with cups, and they're just sitting there loading, print, take it off, reload, print, take it off, reload, print, take, and just repeating that. You're gonna see about 600 to 800 cups per hour. And that will typically have a friction drive or a gear drive piece of tooling. Then our second option, which is pretty much the standard for high speed throughput. Mike, you can take him down that lane and use our current customer as an example.
Yeah, I mean, the most common customer that calls in is either they want to get into cup printing, they have a coffee shop or a brewery or something, or they have, they're a distributor of cups. And all those guys, we start with, how many need to print an hour? From there, F1 DC for your 800 parts an hour. T8SS, probably closer to 1800, maybe 2000, somewhere in that range. That is now both single color high production as well as multicolor high production. When you add that optical registration system, that's gonna, you're not gonna lose too much speed when you're doing the second and third color with that optical registration system, because we're pre-registering before it gets to the print station. So while you're printing, you're also pre-registering, so that when it gets to the print station, it knows, where it's gonna be for registering that color. So there's options for automatically loading that if you have a nice rigid lip. There's other options for flame treating. That's going to be another video altogether when we get into different types of cups, like Frost Flex and Stadium cups, where those are going to be, dishwasher safe, quote unquote. Adhesion matters. You need to pre-treat that plastic with flame when you're doing LED curing. So
yeah, the biggest advantage between the F1 and the T8, why would one person choose an F1 over a T8? Well, an F1, that's a printer only. There's no UV curing or anything on there. So as far as your throughput, if you only need to do if 600 to 800 cups an hour is good enough for you, then chances are you can get away with using an air dry ink.
yeah,
They can put it on, print one, take it off, put it on a table. Next thing you know, you populate this table. And after you populate it with one row of cups, take a big piece of cardboard. What our customers do is they stick it on top of that row. Now they got another surface to populate, and then another piece of cardboard and another blank surface to populate. By the time you're done with your 500 to 1,000 piece order, all those cups are going to be dry. You can, one by one, restack them, slip them in a sleeve, put them in a box, and get ready to ship that order. A T8 is a high production machine, like you said, 1,800 to 2,000 cups per hour. When the cup comes off of that machine, it automatically gets restacked. it has a counter. You're gonna take that stack, slide it into a sleeve, drop it in a box. So the machine performs all of the printing, the UV curing instant of the ink, and it ends up ready to ship as soon as it's off of the machine. So that's really your biggest differences in the machine. One's fully equipped, we can consider automatic. The other one's a semi-auto where you gotta wait to dry.
Yeah, and you can also speed up the drying process for the F1 by putting it through like a hot air conveyor, hot air dryer. A lot of customers will actually start with an F1 and they're using a hot air dry ink. So they're printing each cup instead of putting it on a table to dry. Say it's plastic, and it's going to take a little longer for that to dry than the paper or foam that's a little more absorbent. They'll actually put that through a hot air conveyor. It's much like a t-shirt conveyor. They're just passing it through. They're going, by the time they're out the other end, you might have, you know, a cup coming out every 2-3 seconds, just like your F1 speed, and you can stack them up right off of the hot air conveyor. So we've got customers who have that process, and then they need a little higher production. They need a little more speed. Then they'll jump up to the T8SS after like 2 years, sometimes sooner. We've got customers who have, yeah, we got a customer who has what, 7 or 8 T8SSs, and we got other customers who have racks F1s. So
yeah, we have customers that have dozens of F1s, you know, and they're really versatile, and they'll have, say, 6 F1s and then a hot air conveyor, and then on the other side of the conveyor run another 6 F1s with a long feed in. So you got operators just printing orders, and they're all just sticking them on the conveyor, one conveyor running for 12 machines.
Yeah.
And then we have other customers that have, I think, 7 or 8 T8s all on the line, one dedicated to each cup size, you know. This machine prints 12-ounce plastics. This machine prints 16-ounce plastics. This machine prints 12-ounce foam, just pumping out orders, you know. That's high production. So we do have other machines. Those are just our 2 like most standard machines that we sell the most of throughout the year, but we do have more fully automated. If you wanted to put this cup on a machine and it spits out at the other end and it's a 5-color print, sure, we go fully automated. Machines like our Color Cut Pro, we won't get too much into detail about that machine, but that machine can be equipped up to 6 colors. So the operator is going to load this cup on that machine. They're going to set up the 6 printers. The machine will have 6 UV curing stations, 1 after each printer. By the time the cup is done going through the machine, it has 6 colors printed on it. Your throughput on that machine, you're about, you know, 1,000 to 1,400 cups per hour. But, you know, that's a whole nother video, but we do have much higher levels of automation when it comes to getting into high production, full color printing.
Yep. And then as far as, say, a customer is just purchasing their first screen printing machine for cups, I put together a supplier list, a little cheat sheet, you can call it, for cup printing, which includes all of the ink manufacturers, so Ruco, Nasdar, Marabou. There's maybe Decochem on there, a bunch of different ink manufacturers. So on a daily basis, we're working with any of the, you know, largest ink manufacturers in the industry, whether it's for a new customer, an existing customer. We've got contacts for each of those companies. And then your screens, you're gonna, depending on if you're doing, maybe you're doing stuff for your own company, you wanna just get a few screens, you can have somebody make them for you. If you're gonna be doing something where every morning you're coming in and you've got 10 different companies you're printing for, that means you're gonna wanna make screens yourself. There's a whole process for that. That's a separate video. But yeah, I mean, ink is going to dictate what mesh count you use in these screens. So you can see right through the screen. Open mesh, if you're not familiar with the screen printing process, that's an entire video in itself that we'll get into. But yeah, there's a little bit that goes into cup printing that you need to know for sure.
Absolutely. So what we wanted to make this video just to kind of give you an idea of future future videos. We definitely have a ton more to talk about when it comes to disposable cups, but we just wanted to get you something here on these cups just to start, because there's a lot of information. We can sit here for 2 hours.
Oh yeah.
You're probably going to get bored and click off the video, and we don't want to bore you. So what we just talked about, that's the gist of it. If you call us up tomorrow and said, hey, I saw your video about printing on disposable cups, I'm interested. The first thing we're going to ask you is, number one, are you currently printing on cups? No? Okay. That tells us you're not really familiar with the whole cylindrical printing idea, so we're going to walk you down that lane.
Yeah.
Second would be, what's your throughput requirement? How many cups per hour do you want to print? Okay, now how many jobs per day are you going to print? The reason why we're asking the jobs is because we want to understand what kind of setup times you need. After your jobs, what are your job sizes? Okay, that'll help us understand whether you can get away with using an air dry ink, or if you need to use a T8SS that has UV curing on it, because you need to get these jobs out really fast. You have a lot of jobs, maybe small or large run size, you need to cure that ink right away.
Yeah.
If it was the opposite and we think you can get away with an F1, then we'll go down that avenue. But there's a lot to talk about, and the next video we're going to talk about screens, and then we're going to talk more about the other types of substrates: tumblers, glassware,
Yep.
universal ware holders.
Just drinkware in general, there's way more than just the cup tooling that we manufacture. We dedicated tooling for anything really.
Yeah.
But separate video, way more details to come for stuff like that.
But we hope you guys enjoyed this first video of this
One of many to come.
ongoing, continuing videos that we're going to make. We're really excited to show you the facility, manufacturing. We have a lot of machines, really neat machines that we're making right now, and a lot more really neat machines that are just being started. So it'd be really neat to take them for a tour of the facility and show them everything.
Once it's nice out,
Yeah.
start out front, show you the whole facility,
Yeah.
the lobby, the production process, where we start. Start with a work order. Where does it go from there? The whole deal: cutting, welding,
Yep.
sub-assemblies, everything.
But
Yeah.
thanks for watching.
A lot to talk about in the future. Like the video. That'll help us, bring more, people, more questions, more content. Subscribe if you haven't subscribed already. If this is your first time watching a video, give us some ideas what you want to see. Give us questions, whatever you want to talk about. We'll dig into it.
Yeah, and we'll make sure to link our Instagram account in this video. Comment, put some questions in the comments. We need some stuff to talk about, and we have a million things to talk about, but if we see a priority of a topic, we'd absolutely like to put a video together and talk about that.
Cup printing is definitely a priority. 3 inquiries over the weekend, 2 phone calls today. Cup printing never stops. So
Yeah. All right.
I think that'll wrap it up for this one.
We'll see you in the next video here shortly.
See you guys.